pH metry experiment. So this is the one of the electrical experiment conducted for chemistry for engineers paper. So this is application oriented experiment. So this pH metry is nothing the acidity and alkalinity measurement, whether it is acidic or alkaline, can be determined by using this instrument. Actually, this is termed as potentiometric pH metry because this meter measures the potential difference between the reference electrode which is used in this experiment as well as the ion selective electrode. So in this glass electrode is used as an ion selective electrode. There are many ion selective electrodes. So this glass electrode is especially used for measuring the H plus ion concentration. So this meter shows the accurate measurement for H plus ions. So this is used in many laboratories, especially for measuring the water quality, then parameters like acidity, alkalinity and other parameters which are considering for determining the quality of water. And also it is used in the medical field also, especially the pH level of blood can be measured by the two advanced potentiometric pH meters. So this is what the basic model for pH metry. So in this I am just explaining the titration between the strong acid and then strong base. For that we are taking sodium hydroxide and then hydrochloric acid. So this hydrochloric acid consisting H plus ions, this is what responsible for acidity of the acid, and then sodium hydroxide has OH minus ion, that is hydroxyl ion. So that is what responsible for the alkalinity of the sodium hydroxide. So we can calculate both the sodium hydroxide normality as well as the hydrochloric acid. So in this experiment the HCl normality is given. The sodium hydroxide normality has to be estimated, that means calculated. So for that we have to take the sodium hydroxide in a burette, and then hydrochloric acid is has to be taken in a beaker. So additionally we have to add 20 ml distilled water. So this is what the ion selective electrode. For this meter glass electrode is used as a ion selective electrode. So while we are dipping the glass electrode in this acidic solution, the meter will show the respective reading pH value. So if you are continuously adding the sodium hydroxide from the burette, for each addition the pH measurement will increase there. So after reaching its saturation point, there will be a sudden increase. So after getting that sudden increase, just add 5 to 6 ml of sodium hydroxide, then stop the experiment. Then we have to plot a graph between the volume of sodium hydroxide and then the pH value. From that graph we can get the exact amount of sodium hydroxide required for neutralizing the given HCl. So already we know the concentration of HCl and then volume, that is 20 ml taken for this titration. So we all know volume of hydrochloric acid and then the normality of hydrochloric acid, that which is given already. So we know V1 and then N1. Just to consider volume of hydrochloric acid as V1, normality of hydrochloric acid as N1. So the required amount of sodium hydroxide for this neutralization is considered as V2. So we all know the volumetric principle V1 N1 is equal to V2 N2. So we know what is V1, that is volume of hydrochloric acid, what is N1, that is the normality of hydrochloric acid, then V2 that is what the volume of sodium hydroxide required for the neutralization of HCl. So now we have to find the value of normality of sodium hydroxide, that is N2. So N2 is equal to V1 N1 dividing by V2. By this formula we can find the normality of sodium hydroxide, then multiply it with the equivalent rate of sodium hydroxide 40, then you can get the amount of sodium hydroxide which is present in this given sample solution. This is what the experimental procedure for finding the concentration of the given solution, whether it is acid or base, by using this pH potentiometric method. Thank you.